How? How does your airgun regulator work? Well, whether it's your airgun regulator or the gas regulator attached to your camping gas, or the gas and water regulator in your combination boiler at home, or the regulator on your welding set for the oxygen and acetylene, they're all going to have some of the same components and work in an exceptionally similar way. So there's 5 things that you'll find inside a regulator, and these are going to be a fixed power source, or like with the acetylene regulators, one with a knob on where you can adjust the force, and this force is going to be created by either a conventional coil compression spring, a stack of Belleville spring washers, or in some cases a pocket of compressed inert gas. The next things that you'll find are a large surface area, so it's a component with a large surface area that moves. So this could be a piston, a plunger, or a diaphragm. So a diaphragm is a flexible membrane body which can be either plastic, rubber, or metal. The other part that you'll find is a small surface area. So this could be the knife edge on the end of this piston, so the actual surface area of the knife edge is very small, or it could be a little probe that connects to a ball bearing, so that would be a small surface area. And in this gas regulator here, I don't know if it's possible for the camera to focus, but down inside here there is a little sort of needle of brass, a little bit like the end of this skewer, with a teeny hole coming out the centre of it. So that is the small surface area. And then you'll also have a hard component and a soft component, and the hard component presses onto the soft component to form a seal and to stop the flow of the gas, or if it's a water or liquid regulator, stop the flow of the liquid. So here's a hard component. The hard component on this is the knife edge. This is hard, and this would seat against the soft component, which is the Delrin or nylon insert in the adjuster screw. So when they seat together, the gas ceases to flow. In the case of the Bsa regulator, the hard component is the ball bearing, and it sits down upon the soft O-ring rubber seat and also forms a seal. And when the plunger moves, the little rod lifts the ball bearing off of the seat, and the gas flows between the ball bearing and the rubber O-ring. In the case of this gas regulator, if I can get some light on there and if the camera can see, the soft surface is a rubber insert, black rubber insert here on the end of this brass plunger, and that, if we tip it round, moves back and forth, and the soft rubber presses against the brass needle tip with a hole in and cuts off the gas supply. So the components which you're going to find in all the regulators that you're liable to come across to do with air guns or in many other things in life are the fixed force or power source, which can be the spring, Belleville, or gas, a large surface area, which is most likely going to be a large surface piston, plunger, or diaphragm, a small surface area, which could be the knife edge, or it could be a pin with a little hole in it, or a ball bearing on a rubber seat, and then the soft surface, which could be some Delrin or nylon, a rubber insert or a rubber O-ring, and then the hard surface, which is going to be the component which presses against the soft surface. So the small surface area and the hard component is the knife edge. The hard component and the small component is the ball bearing, and then on here the hard and small component is the brass jet, and the soft component is the rubber insert on the moving piece of brass. So they're the components that you're going to find in all the regulators that you're liable to come across. How? So how does the regulator in your air rifle work? And what are the principles behind this? Well, it doesn't matter whether it's your airgun regulator or the regulators for gas and water in your combination boiler at home. They all work on the same principles. And basically, all a regulator is an opening and closing valve mechanism. And so you can think of that simply as an opening and shutting door. And with all the regulators that you'll come across, the large surface area will be on the output side of the regulator, and the small surface area will be on the high pressure, or in the case of the gas and water in your combination boiler at home, possibly varying pressure side of the regulator. And the regulator simply works, as we said, as an opening and closing valve mechanism. And so, as the pressure on the low pressure or output side of the regulator drops, the valve opens. As gas or liquid passes through the regulator mechanism, the pressure on the output or low pressure side starts to rise, and this closes the valve. So it's basically a case of open, shut, open, shut, open, shut. With each time that you fire your gun, or at home with the combination boiler, when you turn on the tap and the heater comes on, the pressure falls, and so the gas and water valve opens, and when you turn your tap off, it closes again. And that's simply all it is. Now, you're going to be wondering how it maintains it at a constant pressure, and this is very simple, because it just works on the fixed force, which is the spring, the Belleville washer or the gas pocket, and a differential in surface area. So you'll have a small surface area and a large surface area. And so, as you should have learnt at school many years ago, it is difficult to apply great force to a small surface area, but easy to a large surface area. So you could think of that really as being like a tin tack that you'd push a notice into a board with to hold it in place. You'd press on here with your thumb with a low pressure, but that low pressure goes through to become a high pressure on the smaller surface area. So this is what we'll talk about. In your air gun, you've filled it up through the infill valve, and the main reservoir on the input side of the regulator is at 3,000 pounds per square inch. And this basically means a force, or the equivalent of a weight of 3,000 pounds pressing on 1 inch square, which is 645 square millimeters. Now, that force of 3,000 pounds per square inch can only press on this small surface area with a limited amount of force. So it's going to be the 3,000 pounds divided by this small surface area. So for this video, we'll say that roughly there's 10 pounds pressing onto the small surface area. As you fire the gun and the pressure in the reservoir drops, as it drops down towards 100 bar, at 100 bar there's going to be half the amount of the original force. So say there's going to be 5 pounds pressing on the small surface area. So that's a difference of 50%, but it's a 5 pound difference between 3,000 pounds per square inch and 1,500 pounds per square inch. Now, if we reverse that round and we look at the large surface area, the gas on the large surface area side, the low pressure output side, is going to be pressing against the constant fixed force, which will be the spring, the Belleville washer or the compressed gas pocket. Now, to compress the spring, the Belleville washer or the gas pocket, you will have set it to a set amount. So for this video we'll say that this regulator is at 100 bar. So the gas pressing on the low pressure side of the regulator but on the large surface area needs to press that piston back with 100 bar of pressure to close the valve or door mechanism. Now, because this is a constant, that force is going to remain the same. So for this regulator, the force required to close that backwards is, say, 350 pounds to shut the door. Now, obviously, we've got the pressure out of the high pressure side pressing on this small surface area. So the force required on this side, on the low pressure side with a large surface area, is just going to vary by £5. So when the gun is full of air and you've just charged it up, the gas pressure in the output side needs to press backwards with 355 pounds of pressure to close the valve. But when the gas pressure has fallen in here to 1500 pounds per square inch, and just before the regulator stops working, that force on here is varied by £5. And so to shut the valve you're only going to need, pressing on here, 350 pounds of force. And so the pressure drop here has been 1,500 pounds of alteration, but the force required to open and close the valve has only altered from 350 pounds to 355 pounds. And so on all regulators there will be a slight difference in the output pressure as the pressure from the main reservoir alters, but this will be very small, and that is generally simply how a regulator works. And so you've got the small surface area, fixed force and piston, and then the valve, the hard and the soft surfaces are the opening and closing valve mechanism. And so on this one you've got a knife edge which presses onto the soft Delrin seat and forms a seal, and then hopefully, if there's enough light, we can see into this regulator. I hope the camera's focusing. So in here you've got a small sharp pointy nozzle. Imagine the end of this skewer with a little hole in it, and to stop the gas from flowing from the input into the low pressure side, in here hopefully you can see there's a soft rubber insert, and so as the diaphragm moves, this simply opens and shuts and closes off the supply. Now this is also very similar with the Bsa regulator, and on that you've basically got this rod, and as the pressure rises in the output side, the rod moves away and lets the ball bearing onto the soft seat and causes a seal. And when you fire the gun, the fixed force, the spring, pushes forwards, knocks the ball bearing off the rubber seat and lets the gas through until the valve closes again. And so all a regulator is an opening and closing valve, which keeps the output side of the regulator roughly at a constant pressure. And so that leads in general to better accuracy and consistency with your rifle, and it meters out the air more, the power stored within the compressed air, the energy stored within the compressed air, it meters it out more efficiently, and so you can get more shots. And so that's simply how a regulator works.